Closed loop control is an application that you can do with the USB-6211 data acquisition device. In just a moment we'll get into how you would program this application, but first I would like to describe our hardware setup. What we have here is a small battery powered fan, and this fan is going to control the air that's hitting a paper deflector. As the deflector moves back, we're going to be measuring the position of that, and we'll be doing closed loop control to maintain the position of the deflector at positions that we select. So the way the setup is with the USB-6211, we're taking an analog output channel, and over here we're coming into a power transistor. It would be nice if we could just drive this directly with the analog output, but these bus power devices of course don't have that kind of power. So instead we're going to use the batteries that are inside the fan to power the motor, and we're going to modulate that with a power transistor. So we take the analog output coming into the base of the power transistor, and then in the emitter and the collector we're just using that to control the amount of power in the fan itself. So as we change the analog output voltage, the power of the fan will change. On the other side here, as the paper deflector is pushed back, what we have is a cadmium sulfide photocell, and this is just a device whose resistance changes with the amount of light that is striking it. So as the deflector moves back, it decreases the amount of light and changes the resistance. We have a small voltage divider circuit here, and then right in the middle we're going to take this value and we're going to come back into the analog input channel of the 6211. So that's our hardware setup. Now let's go ahead and write a program to make all of this work. So we'll go right into LabVIEW, our graphical programming language. We'll click the right mouse button on the front panel, and we're going to put down a meter. And this meter is going to allow us to see what the position of our paper deflector is, and also what the set point is that we would like to have. First thing that we'll do is we'll scale this, and we'll choose values 4.1 to 4.6. And we've selected this experimentally as we've come to know this system. Alright, next thing we're going to add is a second needle to this, because one will be for the actual position and one will be for the requested position. We'll change the color, we'll click right and we'll go down to Properties, and then we'll choose a blue color for this second needle. We'll click OK, and that's fine. Now we would like to put a slider, and this is going to be our requested deflector position. So we'll put a pointer slider on here, and we'll scale this between our same values of 4.1 up to 4.6. And that's our front panel. So we're ready to go. Let's go back to the diagram now and get our program set up. We'll click the right mouse button, and we're going to put a DAC assistant down here, and we're going to set this up for analog input. So the DAC assistant will ask us some questions. Let's acquire signals, analog input, voltage, and we'll bring it in on analog input channel 0. The next thing that we'll do is tell it to acquire one sample on demand, and we can actually go and run this now, and you can see that we have a value up there. It's about 4.19. Now if I move the deflector back a little bit, you can see the voltage value increasing. So sure enough, as the light decreases on that photocell, we see a change in the voltage. And that looks pretty good. So we'll click OK, and that's good to go. Now at this point we're doing our analog input, and those are the values that we want, and it's working the way that we think it should. But I did notice that it was jumping around a little bit, and that's probably because of the photocell itself or changes in the light. So I think we'll put a filter in between this to smooth that out a little bit. So we're going to go into signal processing. We'll get point by point, we'll go into statistics, and then we'll choose something called a median point by point, and we'll put it in here, and this is going to filter out the noise. So what we will do is we'll wire out of the data acquisition assistant into our median filter, and then I'd also like to tell it to only take a sample of 25 points because it defaults to 100, so we'll take 25 and that should be fine. So now at this point I'd like to wire all of this up. I'd like to wire my slider, that's my position request, as well as the actual position into my meter. And to do this, I have to create something called a bundle that will let me combine these together. So we'll put the bundle down, and now we'll connect all of this up. We'll come out of the slider into one part of the bundle, and we'll combine that with the output of the median filter, and then we'll put that right into our meter. So that's set up and ready to go. All right, let's set up the analog output now. So we'll click the right mouse button again. we'll get the data acquisition assistant, and in this case we're going to generate signals. So we'll generate an analog output in the form of a voltage, and we're going to choose A01 because that's the analog output channel. So we're going to tell it to generate one sample on demand, and we'll click OK, and we're good to go. So that'll go ahead and run. So the next thing that we have to do is put the control algorithm in between this. And so that control algorithm is called PID, and we'll go and select it, and we're going to get a user-created PID routine that we have because it's pretty straightforward. Now if we bring up the help window, we'll drop it down there and we'll bring up the help window, you can see how we wire this up. And the ways that we wire this up is we're going to take the set point, which is our slider. You can remember that that was from our front panel. And we're going to wire that into this PID control so that it will be an input into our PID. And that wires up to something called SP. And we'll click on that, and we'll come up to our slider, and we'll connect it in. So that's fine. The next thing that we'd like to wire in is actually the value that the deflector is at itself. That's coming out of the DAC assistant, the analog output. We'll click on that, and we'll wire it down to PV, or process variable. So that goes right into PV. So that's connected up there. The other thing that we'll do is create controls now that we can set from the front panel for all of the other variables that go into PID. So things that we can set there are the minimum values and the maximum values, and that just limits what the min and max output of the PID can be. And then we'll create variables for the P, the I, and the D coefficients that we'll be able to change from the front panel as well. Alright, so that sets everything up. It's nice and clean now. And finally, we would like to take the output of the PID and wire that up to the real world output of the analog output. So we'll wire that in, and that's set and ready to go. Last thing we need to do here is put it all inside a loop so that it runs over and over again. And then we'll put a control on the front panel so we can shut the loop off when we're ready for it to stop. So let's go back to the front panel, and we have to enter a few values here. The minimum value is 0, so we're all set with that one. The maximum value is going to be 1, I think, because that's going to be a volt, and that will control the max output to the motor. The P, the I, and the D values, let's set the P value to 0.05. Let's set the I value to 0.05. And then we'll set the D to 0.01. Those were values, again, that we determined just by experimenting with the system. So at this point, we're ready to click the Run button and see this work. So at this point, we see the deflector default value is at 4.2, and we're below that, so it can't go any lower than that. We're going to take our set point up to about 4.5, and we'll let it stay there. And at this point, the deflector will begin to move, and it seeks the value. It knows it's outputting just a little too much now, so it'll let off, and it zeroes in on that 4.5 pretty accurately. Let's go ahead and drop it down to about 4.35 or 4.4 in that range, and then we'll see that the fan decreases, it zeroes in, and it holds it pretty accurately there as well. So you can see we've been able to describe our setup here. We've been able to build a graphical program pretty quickly and build a pretty effective controller with graphical programming and the USB-6211. So at this point, that's how you get USB data acquisition and control done with the NI USB-6211.